Last 3 points we see the applications of Gauss theorem. Now our next point is electric potential and potential energy. Now in electric potential is considering only a one charge. So their formula is V is equal to 1 upon 4 pi epsilon naught Q upon R. So potential denoted by V. And then potential energy means work done. So work done in expressed in energy. So formula and is denoted by U is equal to, so potential energy U is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R. This is the difference between potential and potential energy. Potential means considering only one charge, and electric energy considering a two charge, because this is the work done, means charge Q comes near to the Q. So here work done is created and this work done is converted into energy, means work done is nothing but the energy. So formula work done against the electrostatic force is equal to increase in the potential energy of the system. So formula for work done is work is equal to F into S, means force into displacement. Now here displacement is dr. We are considering a small distance between charge Q and test charge. Both are positive charges, and this test charge come near to the Q charges, means is the work done against the positive charge of the electrostatic force. So F into dr is equal to du. Du means increase in potential energy. So where du is the increase in potential energy when the charge is displaced through dr, and F is the force exerted on the charge. Let's see our new point, the expression for potential energy. So refer this figure. So we already know that potential energy, and then formula for potential energy means du is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R. This is the formula. So this is find out from this expression. So let us see this figure. Here plus Q charge situated on a point O, and a Q0 test charge is situated at point A. Now a test charge Q0 come to the point B, and then the distance between OB is R2 and the distance from OA is R1, and electrostatic force exerted by plus Q charge in this direction of Q0. So this work done of the Q charge is against the electrostatic force, because direction of electrostatic force and work done of Q0 is opposite. Okay, so here considering a small displacement of test charge dr, and then find out the total displacement. So we integrating this, we get a total distance. So here now considering a small distance dr. So this figure is charge plus Q0 displaced by dr toward the charge plus Q. Mathematical description. So now work done against the electrostatic force. So therefore du is equal to Fe, means electrostatic force vector, into dr, a small displacement dr vector. So therefore du is equal to minus Fe into dr. This is the vector form and this is the magnitude form, because magnitude form work done is against the electrostatic force. So it shows the minus sign. So integrating this above equation means integration of du is equal to integration of minus Fe into dr. So therefore delta U means small energy is equal to, for the integration of du from R1 to R2, because here test charge come to the point plus Q charge, means from R1 to R2. Okay, distance is R1 to R2. So here we are considering a integration of R1 R2 minus Fe vector into dr vector, because du means this, energy means work done, force into displacement. Above expression we find out this formula. So now Fe means electrostatic force is equal to minus 1 upon 4 pi epsilon naught q naught upon r square into r cap. In 11th standard we already find out this electrostatic force. So 1 upon 4 pi epsilon naught is the constant term, q is our source charge, q naught is our test charge, upon r is the distance from these two charges, so r square into r cap. R cap is the unit vector. So for the system of 2-point charge, means source charge and test charge, so delta U is equal to integration of R1 R2 into du. Let us see again this figure. Here find out integration of point A to B. So means R1 to R2 means A to O point is displacement. So here first we find out a small area dr, then find out a total area. So we get here integrations. So here solving this integration, so du means minus 1 upon 4 pi epsilon naught q naught upon r square into r cap into dr. So delta U is equal to integration of R1 to R2 minus, put up the value of du, 1 upon 4 pi epsilon naught q into q naught 1 upon r square dr. We are not considering r cap because of the magnitude form. So delta U is equal to minus of, now solving these integrations, we put up the outsides of the constant terms outside of the integration. So here constant term is 1 upon 4 pi epsilon naught q and q naught, and the variable term is only r, means distance. So integrating this r1 to r2 1 upon r square dr. So formulate this r, this is written in the form of r inverse 2 minus 2. So r inverse means here minus 2. So this formula for this integration is r minus 2 plus 1 upon minus 2 plus 1 into integration r1 r2. This is the constant. So therefore minus 1 upon 4 pi epsilon naught q naught into minus 2 plus 1 we get minus 1, again here minus 2 plus 1 we get minus 1 into r1 to r2. And this is the reciprocal, because minus, this is the minus, here we get here reciprocal means r minus 1, once again r minus 2. So we can write here inverse term is 1 upon r, and its minus 1 is get here minus sign. Okay, so here minus minus get plus, so 1 upon 4 pi epsilon naught q naught is the delta U in bracket of square bracket of 1 upon r2 minus 1 upon r1. Put up the value of r2 instead of r2 and r1, and this is the minor difference. But change in potential energy means delta U, the change in potential energy is equal to work done by moving charge from A to B against the electrostatic force. So work done, this is the change in potential energy means work done. So point move from A to B. So therefore 1 upon 4 pi epsilon naught, this is nothing but energy. So work done is nothing but energy. So 1 upon 4 pi epsilon naught Q into Q naught 1 upon R2 minus 1 upon R1. So this is the formula for electrical energy, electrical potential energy or potential energy anyway. So in case of this, these 2 points means charge Q and Q naught places at a large infinite distance, means Q naught is placed at far away from the Q. Then what's happened? So if we bring in a charge Q2 from infinity, means R1 is equal to infinite, towards charge Q1 at distance R, then formula delta U means change in energy is equal to 1 upon 4 pi epsilon naught Q1 Q2. Here source charge is considered as Q1 and test charge considered as Q2. So here R2 means distance from referring this R2 means here distance from OB to B to O, means here we are considering Q naught is Q2 and state charge is Q1. Okay, so we get here 1 upon R minus 1 upon infinity, because R1 is the distance from the test charge. So here this test charge is infinity, distance infinity, so 1 upon Q. So we get here formula delta U is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R, because 1 upon infinity means 0.